Hello friends, welcome to an interesting tutorial in digital electronics. We'll discuss the conversion of binary fractions to decimal number. We know that converting a binary number into decimal is pretty easy. That has already been discussed in the number systems tutorial. But what if you have a binary number with a fraction? For example, you have a number something like this 1101.1101. So the theory is pretty simple. It says that to convert a binary number into decimal, we multiply each bit. So we multiply this bit by the binary radix 2 raised to the appropriate positional power. So its positional power is at the 0th place, so 2 raised to the power 0, and this 0 is multiplied by 2 and its appropriate positional power is 1, and so on and so forth. And taking the same concept and extrapolating it on the right side of this decimal number, from this point is the fractional part, and that is what we wish to cover in this tutorial. We wish to convert a binary fraction into decimal. So what do we do with these numbers? Who do we multiply it with? So because we need to convert it into a decimal number and it's a binary number system, so it is surely going to be 2 raised to the power something. But what is going to be the positional power here? So that is the big question. So answering that question, we can say that the positional powers to the right of the binary point are negative and they're not positive numbers. So that pretty much sums up the entire concept. So a normal binary number without a fraction has positional powers 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So that this becomes 1, 2, 4, 8, 16, and so on and so forth. And we do the multiplication of the bits by these numbers quickly and add them up to get the decimal number. So that is going to happen with the positions on the right side of the dot. So they'll have negative powers. So 2 raised to the power minus 1 will be the first positional power, minus 2, minus 3, and as we move along in the right direction of the fraction, this power is going to increase. So what does this power actually mean? So we know that 2 raised to power minus 1 is 1 upon 2 raised to power 1, so this is going to be 0.5. so the multiplier here becomes 0.5. so if there is a 1 here, we are going to multiply it with 0.5, and similarly the second position will have a multiplier of 0.25, because 2 raised to power minus 2 is 1 upon 4, and that is how you can calculate these positional values. So over here it says that the position of this bit is 0th, 1st, 2nd, 3rd, 4th, and this position of this one is minus 1, minus 2. So this can be thought of as an axis with the positive numbers and a negative numbers. And putting this concept into a question, for example, we have a binary fraction 1101.1011. What do we do with that? So first of all, we write the positions, and we know 1, 2, 4, 8 on the left side, and 0.5, 0.25, 0.125, and 0.0625 on the right hand side. So this 1101.1011 will be multiplication of this one with 8 it gives me an 8. This 1 gets multiplied by 4, gives me a 4. This 0 multiplied by 2 gives me a 0, and 1 gives me 1 multiplied 1. So all that adds up to 13. So this number was 13 anyway, we knew that. But the fractional part, this 1 gets multiplied by 0.5 on the same concept level. This 0 gets multiplied by 0.25, 1 gets multiplied by 0.125, and this 1 gets multiplied by 0.0625, and adding these up will give me a fractional value of 0.6875. So all in all, we have the integer value as 13 and the fractional value as 0.6875. So the total number becomes 13.6875. The decimal equivalent of this binary fraction is 13.6875, and the underlying governing concept is the positional powers to the right of the binary point are negative. So this is super important line if you wish to do a flawless calculation of a binary fraction to decimal. And I hope this quick tutorial was of help. If you liked the video, give it a thumbs up, consider subscribing to the channel. I'll see you in the next one. Take care. Bye.